Hello everybody. So in this video we will talk about the reflecting telescopes. Now the telescopes that we discussed earlier, like the astronomical telescope, is a refracting type telescope. Now why is it called a refracting type telescope? Refracting type telescope like the astronomical telescope. Okay, now the reason it is called a refracting type telescope because it makes use of the phenomenon of refraction. Okay, so if you remember, in an astronomical telescope there are two lenses. One is called the eyepiece, which is placed near the eye of the observer, and the other one is called the objective, which is facing the object. All right, and because they are made because lenses are made use in the telescope, the ray of light, after passing through the lens, it will suffer refraction. So therefore that astronomical telescope is a refracting type telescope. But this refracting type telescope has many disadvantages. First of all, it is difficult to manufacture a very big refracting type telescope, because in that case you have to make a very large lens, which is practically impossible. So I will discuss with you why the reflecting telescopes are much more superior than the refracting type telescopes. Okay, now the first refracting type telescope is called the Newtonian reflecting telescope. It was set up by Newton in the year 1668. It consists of a large concave mirror of large focal length as the objective. So that means the concave mirror behaves as the objective, which is made of an alloy of copper and tin. Alright, so let us have a look how it looks like. So this is the Newtonian reflecting telescope. So basically it consists of this mirror out here, a concave mirror. Okay, this is a concave mirror, and the parallel rays which are coming from the distant object, they fall on this concave mirror. So these parallel rays, they suffer reflection. Okay, they suffer what? Reflection or refraction. Reflection. And here also this ray, it suffers reflection. And there is another mirror which is inclined at 45 degree with the horizontal. Okay, this is a plane mirror. So if this plane mirror was not there, then these rays would have come and they would have focused at this point. All right, they would have formed an image at this point. But due to the presence of this plane mirror, which is inclined at 45 degree, the rays are again reflected. One is reflected that way, and another is reflected that way. So these rays now, they go into the lens, which is called the eyepiece, which goes into the eye of the observer. Okay, so basically a beam of light from a distant star. Okay, so these parallel rays, they are the beam of light which comes from the distant star, and they suffer reflection on the objective, which is a concave mirror. Before the rays are focused at F, before these rays come and focus at this point F, a plane mirror inclined at 45 degree, this plane mirror, intercepts the rays and turns them towards the eyepiece adjusted perpendicular to the axis of the instrument. The eyepiece forms a highly magnified virtual and erect image of the distant object. So that is the first reflecting type telescope. Let us now discuss the second reflecting type telescope. And the second one is called the Cassegrain reflecting telescope. Okay, so it consists of a large concave paraboloidal. Instead of just concave, instead of spherical mirror, it is a paraboloidal. Okay, that means parabolic. Paraboloidal mirror, the primary one, having a hole at its center. This one. This is a paraboloidal objective mirror. There is a hole at the center. There is a small convex secondary mirror near the focus of the primary mirror. Near the focus, there is a small secondary mirror, which is a convex mirror. The eyepiece is placed on the axis of the telescope near the hole of the primary mirror. This is the eyepiece. It is placed where? On the axis, near this hole of the primary mirror. Parallel rays from the distant object are reflected by the large concave mirror. So you can see here that these parallel rays which come from the distant object, they are reflected first by this primary mirror, which is paraboloidal in shape. And then these rays, they go and again they get reflected from the secondary mirror. So those rays which are reflected from the secondary mirror, they emerge from this tiny hole. Okay, there is a tiny pinhole out there. They emerge from this tiny hole and they enter the eyepiece. All right. So before these rays come to focus at point F, they are reflected by the small convex mirror and are reflected by this. They are reflected by the small convex mirror to a point I. There is a point I out here. Let me write it with white color. To a point I just outside the hole. The final image formed at I is viewed through the eyepiece. The final image is inverted with respect to the object. Okay. Now suppose if FO is the focal length of the objective and FE that of the eyepiece, for the final image to be formed at the least distance of distinct vision, the magnification is given by this expression. We are not interested in finding this expression, okay? That is done in higher classes. So at your level, it is just important for you to just remember the expression. And for the final image to be formed at infinity, you have M is equal to FO by FE. This part is the same as that of the astronomical telescope, which is equal to R by 2 divided by FE, okay? R here is the radius of the paraboloidal mirror. Is it clear? So these are the two reflecting type telescope. One is this is the Newtonian reflecting type telescope, and another one is this is the Cassegrain reflecting telescope. Thank you.